Good morning and welcome to another nail biting extravaganza. And today I want to look at pages 417 to 419 and we're going to look at the uses of radiation. So let's kick off with uses. Just change the thickness of the pen. Uses of radiation. And radiation is one of these things that we can be very wary of, and rightly so, because it can be rather dangerous. But we're going to look at the benefits of it first. So we're going to look at where we use it in medicine. Now, again, there's good careers in medicine using radioactive sources, right? Like, for example, God forbid, some of us may have to get cancer treated someday with radiotherapy. And radiotherapy is delivered by either a radiographer, so there's a job for you, or a radiologist. And the radiologist is the doctor that does the cancer treatment, and the radiographer would be the assistant who maybe delivers the treatment through the machines, but the doctor would supervise the whole lot. So there's two good career paths. But again, have a look, follow the blue. You go into medicine, you go become a doctor, or you go into university and become, see that path there? You would go into medical, and you don't have to be a doctor, and you become a radiographer. Or you go into medicine and you become a radiologist, and these two people would work together as part of the medical team. And God forbid if you ever get that, that's radiotherapy. And again, we're back down to people like Madame Curie that sort of investigated all those radioactive sources at the start so that this could all be used today. We'll just put this in here when we're at it anyway. We'll just write in the word protective clothing, because protective clothing is needed for these things, and also where these people stand when they're treating you. So if you look at the diagram in 3413, you can see that lady there is, I think she's doing some sort of thyroid treatment, but she'll not stand beside that person whenever she is administering the dose of probably gamma rays. She'll hide in a wee lead room somewhere. So it's a fairly safe job. For the sources used in medicine, there have to be a short half-life. It has to have a short half-life, because if it didn't have a short half-life, it was in your body, it could do the cells, the DNA in the cells, quite a lot of harm. So therefore it must have a short half-life. And it's usually, again, all these things depend upon who's administering them and what they're doing. So usually not alpha sources, because, well, if they're highly ionized and they could do more harm than good, if you're trying to detect this thing, these particles outside the body, well, the alpha particles will be absorbed. So usually not. Fair enough. And I suppose we could then say, if you wanted to become a theatre technician, well, then you could use it to sterilise equipment. So there would be another use. Remember that the medical employment is just not doctors. There's a whole raft of people there, and some of these jobs may suit you. So always think of that. So we'll just put up in here, damage DNA in cells. We don't want to do that. So I'll put a bubble around that one, and again, I'll put an X through it, because then that means, you know, that you really don't want to do that. So then we'll go and we'll have a look at uses of radiation in agriculture. And here's where, for example, you could have tomatoes in the house, and they could be a month old and still don't go off. Well, these could have been irradiated with a radioactive material to kill the bacteria on the surface. And it kills the bacteria on the surface, then it takes some time for the bacteria to re-establish itself and make the fruit or vegetables to go off. So that's their purpose, to kill bacteria. Now, a lot of people don't like eating this fruit or vegetables with that has been that's been irradiated, but most of the time you wouldn't really know. So you can see the benefit of it. Your tomatoes don't go off. You have tomato sandwiches for a longer time. But you can see why people would be worried, because there's no real research into this. So if you have fruit, vegetable that lasts a long time at home, it more than likely has been irradiated. There is no external or internal damage to the fruit or vegetable. You wouldn't know. The other thing you can use it is things like for the uptake of fertilizer. And that's just, you're just using it to monitor where certain elements will go within a plant. And that's just more or less it. The last one, well, it's not really the last one, but it really is. Industry. Well, industry, they do use radioactive tracers. Like, for example, they use beta particles for thickness of aluminium foil. Now, you know why they use beta particles, because aluminium foil stops beta particles. So if you want a certain thickness, you could set up a detector, and if it's the right thickness, the right reading will become on the detector. If it's too thin, the reading's too high. If it's too thick, the reading's too low, and the pressure plates adjust accordingly. It's also used in things like cornflakes packets. Saying, for example, you have a packet of cornflakes and you have them sealed, but you don't know if it has the right amount in it. So you would maybe fire a radioactive source at it. If the cornflakes are there to absorb the radioactive source, there will be a low reading on the detector. If the cornflakes aren't there and the box is sealed, there will be a high reading on the detector, and then you can remove that box from the treadmill. Fair enough. Now, the last one I just want to look at in industry is in pipes, and this is more or less for leakage. And what they do is they usually have a short half-life, because if you're putting a radioactive source into water, the last thing you want to do is poison the country. So it has to have a short half-life, and it probably has to be a gamma source, because the pipes are usually buried, and that's the reason that you use the detector. You don't want to dig up the whole pipe, so therefore the detector will tell you where the leak is approximately, and then you can dig it up at that place. But it has to have a short half-life, because if it had a long half-life, you would damage the people who are drinking the water. Now we're going to go, if we can juke up in here, we'll just talk about the radioactive at home. And the radioactive one at home is more or less a smoke detector. Now, everybody should have a smoke detector in the house. If you don't have a smoke detector, you're a wally. Now, the smoke detector is to detect smoke, and usually with smoke you get flames, and it's got it's got an alpha source in it. It's got an alpha source, and the alpha source is monitored continuously with a detector. And if the smoke gets between, so there's your source, and there's your detector, TCTR, there's your detector. And if there's nothing in here, that means the alpha source just goes to the detector and gives a reading. Now, we know that alpha is stopped by a sheet of paper, so if smoke particles get in here, it reduces the number of alpha particles that are getting across to the detector, and it turns on the smoke alarm. So that's how it works. You should replace your smoke alarm. And why should you replace your smoke alarm? Because the radioactive source half-life will be maybe 8 years. So after 8 years it will not be as effective. So you should replace your smoke detectors. And the last one, if we can get this one in somewhere, it's just your age group, the under 16s. And no contact with radioactive sources. None at all. And this is because your cells are still growing, and you could alter the DNA in them, in the nucleus of the cell, and you could become unwell. So you're not supposed to be near them at all when you're under 16. So that's your age group. So Lord knows why we're doing this in this part of the exam. So there's pages 417 to 419 covered. Again, you can look at this once, bore yourself to death twice. And what I intend to do after this is just continue on down through here. There's a few more pages in this, and then there'll be one more of these that'll hopefully cover most. So if you go now and do the quiz that is associated with that, take it easy. See you shortly.